of this video is on finding volume about a line. Essentially, it's exactly the same thing as washer method, but it's now taking into consideration finding the outer function and the inner function in regards to the line that we're now going to revolve around, whereas it's not going to be the x-axis or the y-axis like it was before. So if we look at example 1, they give us the function y is equal to the square root of x, which we know looks something like this. Y equals 0, which is our x-axis, and the x equals 4. So they want this volume, and they want it to be rotated around the line y is equal to 4. Well, again, we're going to take the function that's furthest away from that axis, which in this case is our x-axis, our x-axis, that's our r of x. And then we also need to take in the closest one, which is our little r of x, in order for us to find the volume. So our outer one is what we're rotating around, so 4 minus our x-axis, which in this case is 0. And then our inner one is 4 minus the function itself, which is square root of x. And we'll be using the washer method for all of these examples. So, just like before, volume will be equal to pi, using our x limits, 0 to 4, of our outer one, which is just 4 squared, minus our inner one, which is 4 minus the square root of x squared dx. We would get pi from 0 to 4 of 16 minus 16 plus 8 square root of x plus x dx. We could then simplify it, get rid of the 16s, integrate. We would get a volume of pi 16x to the 3 halves over 3 plus x squared over 2, evaluate it from 0 to 4, and that would then give us a volume of 104 pi over 3. For our next example, we have y is equal to x squared, y is equal to 4, so we know that would be somewhere about here. Y equal to x squared would look like this, and they wanted to revolve around the line y is equal to 5. So our outer function, keep in mind that for any time we're revolving around a line, you always put the value of that line first. So it's 5 minus the one furthest away, which in this case is x squared, minus the one closest, which is 4. We can simplify that to 1. And again, our method is washer. So our volume here will be from pi, our x values here and here, negative 2 to 2 of our outer function, 5 minus x squared squared, minus our inner function squared dx. Simplifying would give us 25 minus 10x plus x to the 4th minus 1 dx. We could then combine these two and integrate, which would then give us 24x minus 10x squared over 2 plus x to the 5th over 5, evaluated from negative 2 to 2. Using the fundamental theorem of calculus and simplifying, we would get a volume of 832 pi over 15. For this example, we have y is equal to x squared, y is equal to 4, but now we're revolving around the line x equals 3. So now we have to solve for x. So first we have our sketch. And solving for x, we would get y is equal to plus or minus the square root. X equal to plus or minus the square root of y. The one closest is square root of y, and the one furthest is negative square root of y. So for our outer radius, remember taking into consideration what we're revolving around, 3 minus the furthest one away, negative square root of y. The closest one, 3 minus square root of y, and again, it's Washer method. So volume is equal to pi from 0 to 4, because we use the y values now, the y limits, of our outer function. So 3 plus square root of y squared minus 3 minus square root of y squared dy. Foiling it out would give us a volume of pi from 0 to 4 of 9 plus 6 square root of y plus y minus 9 plus 6 square root of y minus y dy. We could simplify by canceling out the 9s, canceling out the y's, and combining these here. We could then pull out the 12, so we'd end up with 12 pi, and integrating square root of y would give us 2y to the 3 halves over 3, evaluate it from 0 to 4, and that would give us a volume of 64 pi. And for our last example, we have y is equal to 2 square root of x, y equals x, and it wants to be revolved around the line x equals negative 2. So let's start with that first. It will be Washer method because we've got two functions. So 2 square root of x, y equals x. They want this here. Furthest one away is our line. Remember that since we're going around a vertical one, we have to have it in terms of x equals. So 2 minus y. And then for the other one, it would be 2 minus 1/4 y squared. So our volume would be from 0 to 4 of our outer function, so negative 2 minus y squared, minus negative 2 minus 1/4 y squared, the entire thing squared, dy. Simplifying, we'd get pi from 0 to 4 of 4 plus 4y plus y squared minus 4 minus y squared plus 1/16 y to the 4th dy. Simplify it further by getting rid of 4, getting rid of y squared. We would then integrate and get pi of 4y squared over 2 plus 1/16 times y to the 5th over 5, evaluate it from 0 to 4, and that would then give us a volume of 96 pi over 5. I hope that this video has allowed you to understand even a bit more Washer method, but now in regards to rotating a solid over some other line, whether it's a vertical or a horizontal, that is not the x or the y axis.